Welcome. In this video, we will take a look at another continuity problem. This asks us to given a function f of x, assign a value to x equals 3 such that the function is continuous. So let's take a look at this function. F of x, we'll notice, is a rational function where our denominator is x minus 3, meaning that the functional value f of 3, this would give us an undefined value. In other words, there's really a hole in the graph at f of 3 currently. So we'd like to assign a value to x equals 3 to make that original function continuous. So let's consider the limit as x goes to 3 of this function. So we have the limit as x goes to 3 of the function x squared minus 7x plus 12 all over x minus 3. Now, if we consider this limit, we can break this function down, and it looks like the numerator might be able to factor. So let's try breaking this limit down and see if we can evaluate it. We have the limit as x goes to 3. The numerator we can factor here as x minus 3 and x minus 4. That will give us a proper factoring of the numerator. And again, we have an x minus 3 factor in the denominator. We'll notice that as we work through this limit, those factors x minus 3's can cancel, and we'll be left with the limit as x goes to 3 of just x minus 4. We can evaluate this limit, x minus 4, at 3, and that would give us 3 minus 4, or what we'll call negative 1. So this is our limit value as x approaches 3. That exists. So this is, in fact, the value that I want to assign to f of 3 to make this function continuous. So if I wanted to rewrite this function, I could write the function here. I'll call this a new function, call it g of x. And this g of x function I can define as a piecewise. And I can define it as our original function f as long as x is not equal to 3, we can be defined as that original function. But at x equals 3, I'll just define the value at negative 1 at x equals 3. Now this new g function is continuous. It is continuous because the original function, g of x, was continuous at all points other than 3. And since I've defined the value x equals 3 to be equal to negative 1 on this function, that combination, or this piecewise function here, is going to be continuous. So this new function g we can call continuous over its whole domain. And that is the completion of this problem. Thanks for watching.